Okay, dear students, today I'm going to talk about Chapter 3, Decision Making for Single Sample. So by the end of this session, you should be able to understand the basic concept of hypothesis testing, identify the appropriate test to be used for a given problem, make conclusion on population parameter using a sample of the population. So suppose that an engineer is designing an air crew escape system which consists of injection seat and rocket motor that power the seat. So the rocket motor contains propellant in order for injection to function properly. The propellant should have a mean burning rate of 50 centimeters per second. So why it should have a 50 centimeter per second? Because if the burning rate is too low, the ejection seat may not function properly and it may lead to unsafe ejection and then possible injury for the pilot. Also, if the burning rate is too high, again leading to instability in the propellant or ejection seat is too powerful, again it's leading to possible injury for the pilot. So the question here is, do the mean burning rate is equal to 50 centimeters per second or not? So the engineer, he's designing the air crew, he has to test whether the mean burning rate is equal to 50 or not. So this question can be answered using statistical technique called hypothesis testing. So what is hypothesis? Hypothesis is a claim or a statement about the population parameter. What are the population parameter? We have many parameters we have studied already, like population mean, population standard deviation, or we are talking about proportion. So hypothesis testing is a part of inferential statistics where you have to draw conclusion about the population, but you are going to use a sample in order to make a conclusion about the population. So suppose this is your target population and you want to make a decision about this target population. But sometimes you are not able to reach each element of your population, or it costs you a lot of time to reach all the element of the population. So in that case, what you are going to do, you have to take a sample such that this sample represents the population. Okay, suppose for example you want to know the average or the mean age of National University student. So you cannot get the data for all students. You cannot reach all students. So what you have to do, your target population is all the National University students who are registered in the college on a specific year. Now, in order to know the mean age, what you have to do, you have to take a sample from the target population such that this sample represents your population. And then you have to compute the mean of that sample, the mean age of that sample. So what we are talking about here is when we compute the mean for the population, then we are talking about population mean, and it is denoted by mu. For example, if we want to compute the variance for the population, then that variance is denoted by sigma square. So these symbols are used for the population. So whenever you see the mu symbol, it means it's a population mean. Whenever you see sigma square, it means we are talking about population variance. When you compute the sample mean, then it means you have computed X bar. Also, whenever you talk about the sample variance, the variance you computed using your sample, then in that case you're talking about S square. Let's take an example. Suppose you have a company which produces a light bulb and you claim that the mean lifetime of your company light bulb is 1580 hours. Then a customer came to your office and said that the mean lifetime of the light bulb is different from what you claim. So we have two claims here. One is your claim. You are saying that the mean lifetime of light bulb is 1580 hours. And the opposing claim is the customer claim that mean lifetime of the light bulb is different from 1580 hours. So in this case, what we have to do, this is hypothesis testing. So you need to test these two claims. So there are two opposing claims. So there are two opposing hypotheses. Now, in order to test this claim, what we do normally in statistics, we take, because we cannot test each light bulb, all the target population of our company, we have to take all the light bulbs and test whether the lifetime of the light bulb is, the mean lifetime is 1580. So what we have to do, we have to take a sample from the population, from the company, and test. So what should be the size of the sample? It depends on some calculation. You decide how much you have to take from your population. So let's say that in this case, we took a sample of 50 light bulbs and we found that the sample mean is 1500. In the beginning, what we said that the mean lifetime of your company light bulb. So here we are talking about the population mean because you are considering all the light bulbs in your company. So this value is for the population mean. So this is your mu. And when you took a sample and you found the average lifetime for the sample, then in that case you're talking about X bar. So this is your X bar and that is your mean for the population. Now, if you see there is a difference, but we cannot decide based on this. So we cannot, so shall we reject your hypothesis or accept your hypothesis? That is the question, and that you are going to do in order to, that you're going to do in the next step, okay? So what are the steps you need to do in order to reject this claim or accept this claim? So as I told you, there are two opposing hypotheses. One is your claim, the other one is the customer claim. So what we call these two claims, one we call it null hypothesis, and this hypothesis or this statement is what you want to test it, that is the null hypothesis. Alternative hypothesis usually is a statement that you might believe it is true or you try to prove it is true. Null hypothesis is denoted by H0 and alternative hypothesis is denoted by H1. Null hypothesis is always has an equality sign. So when you are saying that mean lifetime is 1580 hours, it means you are saying the mu is equal to 1580 hours. And the alternative hypothesis, it never has an equality sign. It has not equal sign or less than or greater. So your claim, you are saying that the mean lifetime of a light bulb is 1580 hours. So that is, as I told you, that whenever you in the null or alternative hypothesis, we are going to write about the population mean. So here your population mean is 1580 hours. So in the null hypothesis, we always take the equality sign. So we are going to write that mu is equal to 1580. Now your customer claim, it is different from 1580. So that comes under the alternative hypothesis. We are going to write that the population mean, which is mu, is not equal to 1580. So that is the way you write your statement. two statements in hypothesis testing. What are the other procedures for hypothesis testing? We will learn that in next video.